Hello there, and welcome back to Science to Fall Asleep To. I'm glad you've found your way here tonight. Maybe you've had a long day, or maybe you simply prefer to drift into sleep with thoughts of vast horizons and timeless mysteries. Either way, you are in the right place. All you need to do now is rest. Let your body grow heavy against the bed and allow your thoughts to grow light, as though gravity itself has loosened its hold. Tonight, you are not bound to one world. Tonight, we will drift together through the system of planets, moons, and wandering bodies that form our cosmic neighborhood. There is no hurry. Just breathe slowly and let the story carry you. And while you're settling in, before your eyes grow too heavy, I'd love it if you gently tapped subscribe or press the little hype button YouTube recently added. It's a small click, but it helps keep these experiments and explorations orbiting out into the algorithm. You can also leave a comment telling me where you're listening from and what time it is in your corner of the night. It's oddly fascinating to see where people are drifting off with us, scattered across the world like stars across the galaxy. Now take a deep breath, let your day drift away, and let's travel together into the quiet corners of the universe. Our journey begins at home, beneath the quiet dome of the sky. From Earth's surface, the solar system seems like something far away, but in truth, we are inside it, wrapped in its movements and bathed in its light. Every second, streams of energy from the sun flow past us. Every night, the moon and the planets wheel overhead, marking out paths older than history. You do not need to go anywhere to be part of this story. You already are. Imagine the sun, the luminous heart at the center of it all, a great sphere of fire and fusion, older than all the worlds that circle it. Its light crosses space in just over 8 minutes to reach your face, warming your skin, guiding your seasons, making every breath you take possible. Around it, the planets sweep along their orbits in a slow and measured dance. Mercury rushes ahead, Venus glows fiercely in twilight, Earth spins steadily with its oceans and forests, Mars drifts red and quiet, while beyond them, the giants, Jupiter, Saturn, Uranus, Neptune keep their ancient watch at the far edge. Even farther, small icy worlds wander in the dark, half forgotten, but still part of the whole. Together they form a family bound by gravity and time, circling endlessly, a system complete unto itself. The solar system is not just planets, though that is how we often picture it. It is also moons in great numbers, from Earth's solitary companion to Jupiter's retinue of more than 80. It is asteroids tumbling in silence, some as small as a pebble, some large enough to rival cities. It is comets that fall inward, trailing luminous tails, relics of the system's birth. It is meteors that streak across Earth's skies in sudden sparks, tiny fragments of ancient stone and ice burning briefly into memory. All of these, together, are part of the system we live within. It may seem still from where you are lying, but everything in the solar system is always moving. Earth spins on its axis, turning night into day. The moon circles Earth, tugging at the oceans and shaping the tides. Planets race and drift, some completing an orbit in weeks, others in centuries. And all of this sun, planets, moons, asteroids, comets, is itself in motion, carried together around the Milky Way in a journey that will take hundreds of millions of years to complete. You are not simply on Earth. You are part of a vast and moving system, an intricate clock whose hands sweep silently across ages too long for any one life to measure. As you listen, try to picture yourself floating gently outward, away from the noise of Earth, through the soft layers of atmosphere, into the quiet beyond. From up here, the solar system spreads out in every direction, a great wheel of light and shadow. The sun shines at the center, brighter than any thought can hold. Around it, the planets form paths invisible to the eye, but no less real. Some shine faintly in the darkness, others glow with reflected light. and between them lies so much space, so much emptiness, that the scale is almost impossible to imagine. Even the moon, which seems so near, is nearly 400,000 kilometers away. Jupiter, the giant, lies hundreds of millions of kilometers beyond that. The numbers are too vast for the mind to grasp, but they remind us of the truth. Space is not crowded. It is wide, it is deep, and it is patient. Still, for all its size, the solar system is a kind of home. The planets are like rooms in a house, each with its own shape and weather, its own history and fate. Mercury, scorched and barren, racing in the sun's light. Venus, veiled in clouds and heat. Earth, full of rivers and air and life. Mars, a desert with ice at its poles. Beyond them, the gas giants and their many moons, vast spheres of hydrogen, storms, and hidden oceans. And past even these lie the icy bodies of the Kuiper belt, drifting at the edge like old forgotten toys in the attic. They are all bound together, sharing the same parent star, woven into one system of motion. The story of the solar system is also your story. The atoms in your body, the iron in your blood, the calcium in your bones, the oxygen in your lungs, were shaped long ago by stars that lived before the sun was even born. That material gathered here, into this system, into this world, into you. You are part of this cosmic neighborhood in ways that go deeper than simply living on Earth. You carry its history inside you, written in elements and light. As you lie here tonight, breathing quietly, think of yourself not as a small figure beneath a distant sky, but as a piece of the solar system itself. You move when it moves. You spin when Earth spins. You drift through space, held in the orbit of the sun, as surely as any planet or moon. You are within its gravity. You are within its story. Tonight, we will wander slowly through this family of worlds. We will meet the planets, the moons, the rings, the comets, and the forgotten fragments of stone. Some of what you hear may surprise you. Some may simply soothe you, reminding you of your place in something wider than worry or time. The solar system has been here for billions of years. It will continue long after us. But right now, it is here for you, steady and quiet, turning slowly, like a lantern in the dark. And so we begin. The sun glows at the center, and from it, the solar system unfolds. Around it, the planets wait in their paths. Beyond them, the icy frontier lies in silence. And you, here, resting in your own orbit, are ready to drift through it all. At the center of our solar system, everything begins with the sun. It is not only the largest object in our neighborhood of space, but the reason this neighborhood exists at all. Over 4.5 billion years ago, a cloud of gas and dust collapsed under gravity, and from its dense heart, the sun was born. Since then, it has burned without pause, pouring light and warmth across the vast reaches of space. It makes up more than 99% of the solar system's mass, so large that over 1 million Earths could fit inside it, and yet it holds itself together with a delicate balance of pressure and gravity. It is a sphere of fire in constant motion, a star that beats like a heart and whispers in light. The sun's energy comes from fusion, a process so powerful and relentless that it is hard to imagine. Deep within its core, hydrogen atoms are pressed together with such force that they fuse into helium, releasing immense amounts of energy in the form of light and heat. Every second, the sun converts about 600 million tons of hydrogen into new elements, creating an output that has not faltered in billions of years. The light we see tonight began as energy at its core, took thousands of centuries to travel through the layers of plasma, and then crossed space in just over 8 minutes to fall softly on Earth's oceans, mountains, and skin. Every sunrise is a message sent long ago, a continuation of that quiet nuclear fire burning ceaselessly at the center. From a distance, the sun seems smooth and perfect, but its surface is restless. Vast currents of plasma rise and fall, Dark sunspots appear where magnetic fields twist and knot. Tremendous arcs of flame, called prominences, stretch far above the surface, sometimes taller than entire planets. At times, the sun releases sudden bursts of energy known as solar flares, explosions so powerful they can release more energy in minutes than all of Earth's human civilization's combined use in decades. These flares send shock waves of charged particles into space, sometimes reaching Earth, where they can disrupt satellites, black out radio signals, or paint the skies with shimmering auroras. The sun does not only give light, it breathes. From its surface flows the solar wind, a steady stream of charged particles racing outward across the solar system. This wind shapes the space environment, carving invisible paths through the darkness. It forms a protective bubble around the system called the Heliosphere, stretching far past Pluto and into the deep interstellar medium. Within this bubble, every planet, moon, asteroid, and comet feels the presence of the sun's breath. On Earth, when these particles meet our magnetic field, they spiral toward the poles and ignite the atmosphere in curtains of green and violet light. The aurora is not just beauty, it is the visible trace of the sun's constant touch. The sun is not eternal. Like all stars, it has a life cycle, though one so long that it dwarfs all human time. It is now in its middle age, steady and calm, shining at the same brightness for billions of years. One day, though, it will change. In about 5 billion years, the hydrogen in its core will thin, and the sun will swell into a red giant, engulfing Mercury, Venus, and perhaps even Earth. Later still, it will shed its outer layers into space, leaving behind a dense remnant called a white dwarf, cooling slowly in the dark. But tonight, and for every lifetime you could ever imagine, it is steady. It is a star in its prime, burning quietly, sustaining all life here on Earth. The sun is vast beyond comprehension, but it also connects intimately to every breath you take. The warmth on your face in the afternoon, the growth of every leaf, the rhythm of the seasons, all come from its constant glow. Without the sun, Earth would be a frozen world, silent and dark. With it, the planet is alive. You carry its energy in your body every day, not just as warmth, but in the food you eat, in the air you breathe, in the very chemistry of life. Plants turn sunlight into sugar through photosynthesis, and those sugars form the foundation of all food chains. Even the fossil fuels we burn are remnants of ancient sunlight, captured by life long ago and stored underground for millions of years. The sun is not distant, it is woven into you. Look at it from another angle, and the sun is a quiet conductor of balance. Its gravity holds the planets in their orbits, prevents them from drifting into the emptiness, and sets the pace of their journeys. Mercury speeds around in just 88 days, while Neptune takes 165 years, but each one is bound by the same invisible thread. The sun is the reason the planets circle at all, a great anchor in the dark. Without it, the solar system would scatter. With it, the system turns in harmony, a vast clock with hands of stone and ice. The surface of the sun is called the photosphere, and though it looks like a sharp edge, it is not solid. It is a boiling layer of plasma, about 500 kilometers thick, glowing at nearly 60 degrees Celsius. Above it lies the corona, the sun's faint outer atmosphere, visible only during eclipses as a delicate halo of light. Though faint, the corona is paradoxically hotter than the surface itself, rising to millions of degrees. It is from here that the solar wind escapes, carrying streams of plasma outward like breath exhaled into infinity. The corona is a crown that marks the sun as both gentle and fierce. At night, when you look up, you cannot see the sun, but you feel its presence in the darkness. The planets shine by reflecting its light. The moon glows because it catches its rays. Even comets grow luminous tails only when the sun's warmth reaches them. Its influence stretches across billions of kilometers, shaping every body it touches. It is the quiet background to everything, the hidden force behind every gleam in the night sky. If you imagine the solar system as a great living body, the sun is its beating heart. It pulses, not with sound, but with light. Its rhythm is steady, carrying warmth and energy outward in all directions. You are living in the glow of a star. Its light falls on oceans, mountains, forests, and cities, unbroken since the first life stirred on Earth. Long after you are gone, long after civilizations rise and fall, that light will still pour across the void, steady as breath. The sun is not just a distant star. It is our living star, our furnace, our anchor, our constant flame. And tonight, it burns for you. Mercury is the smallest of the planets, a world of stone and silence that races endlessly around the sun. It is the innermost planet of the solar system, closest to the great furnace at the center. And yet, despite its nearness, it is often overlooked. Seen from a distance, Mercury is unassuming, a gray, scarred globe marked by craters and ridges. But step closer in thought, and you find a restless world of extremes, a planet of fire and frost, of speed and stillness, a messenger that carries the scars of the early solar system. Its size is modest, smaller even than some of Jupiter's moons, yet its proximity to the sun makes it something more dramatic than its scale suggests. Because Mercury lies so close to the sun, it completes an orbit in just 88 Earth days, circling with a swiftness unmatched by any other planet. To observers in the ancient world, this quick darting motion across the sky made Mercury a symbol of messengers and speed, and even today its dance reflects that identity. But its orbit is not simple. Mercury is locked in a strange rhythm with the sun, one that shapes its days and nights into patterns unlike any other world. A day on Mercury is a puzzle of time. The planet rotates 3 times for every 2 orbits it makes around the sun, a resonance born from the tug of gravity and its own slow spin. Because of this, one full day from sunrise to sunrise lasts 176 Earth days. Imagine standing on its surface, watching the sun climb in the sky not in hours but in months. The star at its horizon would rise, pause, drift backward, and then continue forward again, as if caught in some cosmic hesitation. Mercury's day is a restless paradox, where the clock runs on a rhythm all its own. And what a day it is! On its sunlit side, Mercury's surface can reach temperatures of 430 degrees Celsius, hot enough to melt lead, the rocks glowing with heat under the unfiltered blaze. Yet in the shadows, the cold is profound. With no thick atmosphere to carry warmth, the night side drops to minus 180 degrees Celsius, colder than the frost of Pluto. Here is a world where the swing from fire to ice is sharper than anywhere else. A planet defined by extremes that press against one another on the same stony crust. The landscape itself tells the story of a battered survivor. Mercury's surface is covered in craters, relics of an ancient era when the solar system was young and collisions were frequent. Some craters stretch hundreds of kilometers across, their rims shattered and their basins filled with shadows. Others overlap in chaotic clusters, scars upon scars etched over billions of years. Among these is the Heliosphere Basin, one of the largest impact features in the solar system, so vast it could swallow a continent whole. The violence that carved it shook the entire planet, creating ripples on the far side where the crust buckled from the shock. Mercury wears its wounds openly, a reminder that it has stood close to the sun since the beginning and endured the violence of the early cosmos. Though it looks solid and still, Mercury carries restless secrets beneath its surface. Its core is disproportionately large, taking up most of the planet's volume, and it remains partly molten. This inner activity generates a weak magnetic field, one of the few among rocky planets besides Earth. It is faint compared to ours, yet enough to shape interactions with the solar wind. Charged particles streaming from the sun crash into Mercury's field and surface, stirring up faint glows in its thin veil of gases, an exosphere so fragile it is almost not an atmosphere at all. This exosphere is born from atoms knocked off the surface by the sun's relentless radiation and by micrometeoroids striking like tiny hammers. Sodium, oxygen, and other particles drift outward in tenuous wisps, a ghost of an atmosphere that never shields, only whispers. Mercury's closeness to the sun makes it difficult to see from Earth, often drowned in the glare of daylight. It appears briefly in twilight, a faint dot near the horizon, vanishing quickly back into the glow. This fleeting visibility gives it a quality of elusiveness, a world always near yet rarely seen. For spacecraft, too, Mercury has proven challenging. Its proximity to the sun demands immense precision to approach, as gravity pulls hard, bending paths steeply inward. Yet the few missions that have reached it, like Mariner 10 and Messenger, revealed more than we ever expected. Mapping its surface, tracing its magnetic field, and uncovering hints of water ice hidden in craters at the poles. That ice is one of Mercury's strangest contradictions. In the permanent shadows of polar craters, where sunlight has never touched, temperatures remain cold enough to trap ice for billions of years. Radar reflections suggest thick deposits of frozen water buried beneath layers of dust. On a planet scorched daily by heat, there are pockets of eternal frost, a reminder that even the closest world to the sun carries a touch of the cold depths. Mercury's orbit itself is a story written in the language of physics. The pull of the sun bends its path more than Newton's laws predicted, and for centuries astronomers puzzled over the discrepancy. Only Einstein's theory of general relativity explained it fully, showing how space itself curves around the sun and how Mercury's orbit, with its subtle precession, bears the mark of that curvature. Mercury became not just a planet, but a proof of the way gravity bends the universe. To imagine Mercury is to imagine a world that never rests. It is pulled and twisted by the sun's gravity, scoured by solar wind, blasted by ancient impacts, and swung between searing heat and bitter cold. Yet it endures, small but resolute, racing through its orbit faster than any other planet. It is a survivor of cosmic violence, a messenger of extremes, a reminder that even in the places closest to fire, stillness and silence can hold. And so, Mercury continues on its path, circling every 88 days, turning slowly on its axis, bearing its craters and scars without complaint. It has no thick atmosphere to cushion it, no oceans or forests to soften its face, no clouds to veil its wounds. It is exposed, unguarded, open to the void. But in that exposure lies a kind of purity. Mercury is a record of what the early solar system was like, a witness that has carried its memories for billions of years. When you see it low in the twilight, a small gleam against the fading blue, remember that you are looking at a world both fragile and fierce, a restless stone that forever circles the sun, the scorched messenger that endures. Venus is often called Earth's twin, a planet almost the same size, almost the same mass, almost the same density. At first glance, it feels like a mirror, another world that should have been a sibling to ours, a place where oceans might have shimmered and winds might have carried the scent of rain. Yet, when we look more closely, the reflection turns harsh. Venus is no gentle twin. It is a mirror warped by heat and poison, a reminder of how fragile balance can be. The resemblance is there, but it is the kind of resemblance that carries unease, as if the universe showed us what might have been, had our own story tilted just slightly differently. Beneath the pale golden glow that makes Venus the brightest planet in our sky lies a world wrapped in clouds. They seem soft from Earth, luminous and pearly, yet those clouds are not made of water but of sulfuric acid, thick and corrosive. They blanket the entire planet, shrouding it in an endless veil that hides its surface from view. For centuries, we wondered what lay beneath, whether forests or seas might be waiting under those layers. But spacecraft that pierced the atmosphere discovered something far less hospitable. The clouds are a prison. They trap the planet in a greenhouse so fierce that the surface bakes at 465 degrees Celsius, hot enough to melt lead, hot enough to cook any machine sent down in hours. This is no Eden. This is a furnace. The air itself weighs like an invisible ocean. At the surface of Venus, the pressure is 90 times greater than Earth's, the equivalent of standing nearly a kilometer underwater. The crushing force makes survival impossible. A spacecraft descending through the atmosphere feels both heat and weight, a relentless combination that destroys most machines within minutes of touching the ground. The few images we have from its surface come from Russian landers that lasted no more than 2 hours before the heat and pressure silenced them forever. They showed us a barren plain of rocks and fractured slabs, a place where the horizon wavered in the haze, distorted by a shimmering furnace of air. Yet there is a strange beauty in its violence. The clouds reflect sunlight so brilliantly that Venus is often the evening star, glowing just after sunset, or the morning star, bright before dawn. It has inspired poetry, myths, and longing for thousands of years. To see it rising in twilight is to see hope and mystery, even while knowing that beneath that glow lies a surface utterly hostile to life. The contrast between its beauty from afar and its brutality up close makes Venus a paradox, a jewel in the sky that hides a nightmare beneath its gleam. The heat of Venus comes from more than its closeness to the sun. In fact, Mercury, nearer still, is not as hot on average. What makes Venus extraordinary is the runaway greenhouse effect. Carbon dioxide dominates its atmosphere, a thick blanket that traps sunlight and turns the whole planet into an oven. Once, long ago, Venus may have had oceans, perhaps shallow seas glimmering under a young sun. But as the planet warmed, water evaporated into the air, and the vapor itself acted as a greenhouse gas, amplifying the heat. The oceans boiled away, leaving only dry ground. Without water to bind carbon dioxide into rocks, the gas accumulated in the atmosphere, thickening the blanket until no escape remained. It is a cautionary tale written in stone and cloud, a reminder of how small shifts in balance can change a planet's destiny forever. The surface of Venus is dominated by volcanic plains, stretches of basalt that cover most of the landscape. Vast lava flows froze into smooth expanses, broken by mountains, ridges, and collapsed calderas. Some regions are marked by immense shield volcanoes, larger than anything on Earth, though quieter now. Radar images taken by orbiters show channels carved by rivers of lava, stretching hundreds of kilometers, and strange circular features known as coronae, formed by plumes of molten rock rising from below and distorting the crust. Whether Venus is still volcanically active is uncertain, but evidence suggests it may be. Sulfur dioxide levels in its atmosphere rise and fall, as though something beneath still breathes fire, exhaling in plumes invisible through the clouds. Above the surface, the winds howl. At the cloud tops, storms race around the planet at speeds of hundreds of kilometers per hour, whipping the atmosphere into a perpetual super-rotation that circles faster than the planet itself turns. This creates a strange duality. While the air rushes around, the planet beneath rotates with extraordinary slowness. A single rotation takes 243 Earth days, longer even than its orbit around the Sun. And to make it stranger still, Venus rotates backward compared to most other planets, so its sun rises in the west and sets in the east. Days and years twist into odd rhythms, time itself bending differently on this fiery twin. Despite all its hostility, Venus is not without mystery. High in its clouds, at altitudes where temperatures and pressures are less extreme, some scientists wonder if conditions might once have allowed something to exist, perhaps not life as we know it. but microbial forms adapted to acid and cloud. Traces of unusual chemicals have been detected there, sparking debate over whether they could be the signs of biology or merely the echoes of unknown chemistry. Nothing is certain, but the thought lingers. Could even a place so fierce hold a secret life, hidden in its stormy veil? To look at Venus is to look into a distorted reflection of Earth, to see what might have become of our own world if oceans had boiled away and the air had thickened into suffocating weight. It reminds us that planets are not static but change over time, sometimes gently, sometimes catastrophically. Venus once may have been temperate, a sister with seas and skies not unlike ours, but the path it took led elsewhere. Now it glows like a warning lantern in the night, radiant but inhospitable, a mirror turned hostile. And still, despite everything, it captivates us. The evening star that lingers after sunset, the morning star that greets the dawn. It shines brighter than nearly anything else in the sky. Ancient peoples saw it as divine, a goddess, a herald, a symbol of love and war. We, with our telescopes and spacecraft, see it differently now, yet the pull remains the same. Venus is a twin we cannot embrace, but one we cannot stop watching. It is both beautiful and terrifying, a lesson and a lure, forever gleaming at the edge of our twilight. In the vast silence of the solar system, there is one world where oceans breathe, where forests whisper, and where life has taken hold in endless shapes and colors. Earth, our oasis, spins quietly beneath a veil of blue atmosphere, fragile yet resilient, balanced in a narrow band where warmth and water can endure. It is the only place we know where the cosmos has awakened into self-awareness, where matter has shaped itself into eyes that look back at the stars and wonder. Against the backdrop of frozen worlds and fiery giants, Earth glows as a rare flame of life in the dark. The air we breathe is not just a shield but a careful balance. Nitrogen fills most of it, silent and steady, while oxygen fuels our lungs and the fires of metabolism. Trace gases like carbon dioxide and methane help hold warmth, keeping the planet from freezing, but never so much that they burn it into ruin. This balance is delicate, the result of billions of years of interaction between life and stone, ocean and sky. Plants and cyanobacteria filled the air with oxygen long ago, reshaping the planet and making it habitable for creatures like us. The atmosphere is both protection and invitation, scattering sunlight into a blue dome by day and glowing with auroras by night as charged particles from the sun dance along magnetic lines. It is thin compared to the bulk of the Earth, yet without it, life would vanish in an instant. Water is the defining element of Earth, the substance that gives it voice and vitality. Oceans cover more than 2/3 of the surface, vast reservoirs of salt water that cradle storms, currents, and life. Rivers carve valleys, glaciers grind mountains into dust, and clouds drift overhead, carrying rain across continents. In its liquid form, water connects everything, cycling endlessly between sea, sky, and land. It dissolves minerals, nurtures roots, and provides the chemistry that allows cells to live. Few other places in the solar system allow water to remain liquid on the surface, and it is this rarity that makes Earth an oasis. The sight of a river flowing, of rain falling, of waves rolling against a shore is a quiet miracle in a cosmos where most water hides as ice or vapor. Beneath the surface, the Earth is restless. Its crust is divided into plates that drift slowly across a molten mantle, colliding and pulling apart in a slow dance of creation and destruction. This tectonic activity builds mountains, shapes continents, and fuels volcanoes that pour molten rock and gases into the sky. It also recycles carbon, locking it into stone and releasing it again, maintaining the balance of the atmosphere over vast spans of time. Without this deep, hidden engine, Earth might have gone stagnant, its air thickened or depleted, its surface eroded into silence. Instead, the planet renews itself, shifting slowly, breathing through fire and quake. Above it all, The moon keeps watch. Though small compared to Earth, its presence is profound. Its gravity steadies our planet's tilt, preventing wild swings that could bring chaotic seasons. With this stability, climates remain gentle enough for ecosystems to thrive. The moon also stirs the oceans, raising tides that sweep coastlines and drive currents, mixing nutrients, shaping shores, and influencing the rhythm of life itself. Even in the stillness of night, the moon's glow reminds us that Earth is part of a system, its fate intertwined with another body in an endless gravitational embrace. Without the moon, Earth would be less steady, less fertile, less secure. Life, once it began, reshaped the planet into something even more extraordinary. Microbes altered the air, plants spread across continents, and animals filled every niche from the depths of the ocean to the highest mountain slopes. Over billions of years, the biosphere and the Earth itself became inseparable, each changing the other. Forests capture carbon and breathe oxygen. Coral reefs build stone skeletons that shape coastlines. Even the smallest organisms leave their mark, layering sediments and sculpting chemistry. The Earth is not simply a backdrop for life. It is alive in partnership with it, an intricate weaving of rock, air, water, and biology into a single, evolving system. And within this, humanity has found its place. We are born from the same elements as stars, carried by the same water that has flowed since the planet's earliest days. We walk on land made from ancient volcanic eruptions, breathe oxygen exhaled by countless generations of plants, and eat food that grows from the soil of continents still drifting. Our existence is tied to cycles older than our species, older even than our world as it now stands. Yet we are part of the Earth's story, participants in its unfolding, caretakers of a rare and fragile home. Earth's uniqueness is not simply in its habitability, but in its balance. Too close to the sun, and oceans would have boiled like those of Venus. Too far, and they would have frozen solid like those of Mars. Too little atmosphere, and radiation would scour the surface bare. Too much, and pressure and heat would smother everything. Instead, Earth occupies a thin band of possibility, a narrow window where complexity can flourish. This narrowness is humbling, a reminder that what we call normal breathable air, flowing water, seasons of growth, is not common across the cosmos. It is rare, it is fragile, it is precious. When astronauts look back from orbit, they describe Earth as a fragile sphere of blue and white, a thin shell of life floating in the black. No borders are visible, no divisions of nation or language, only a glowing curve of light wrapped in atmosphere and ocean. To see Earth from space is to see its vulnerability and its beauty in the same glance, to realize that this oasis is both vast and small, abundant and yet limited. From that distance, it is clear that everything we know, everything we are, depends on this thin, glowing shell. Even as Earth drifts through space, it remains part of a larger cosmic story. It shares the solar system with barren planets, frozen moons, and distant comets, yet it alone blooms with green and blue. Its life is both rare and, perhaps, inevitable, the result of chemistry given enough time and the right conditions. Whether other worlds hold their own versions of this miracle is a question we cannot yet answer. But for now, Earth stands as a singular oasis, a reminder that in the cold expanse of space, warmth and water and breath can coexist, that life can arise and look upward. In the quiet of night, when you step outside and feel the air against your skin, you are touching the balance of billions of years. Every breath carries atoms forged in stars and recycled through oceans. Every sip of water has flowed through ancient rivers and clouds countless times. Every glance at the moon is a reminder of Earth's steadying partner. We live not apart from this planet, but within it, inseparable from its cycles, its history, and its future. To know Earth is to recognize that it is not guaranteed. that its stability is not eternal, but that for now it holds us in its rare and fragile embrace. And in that embrace, life continues. The tides rise and fall, the continents drift, the forests breathe, the air carries whispers of storms and sunlight. Earth spins, a luminous oasis turning slowly through the dark, carrying us all on its back, the rare home where life found its foothold and dared to bloom. High above Earth, patient and silent, drifts a world that has circled us for billions of years. The moon is our constant companion, always present though never speaking, watching over oceans, forests, deserts, and cities as they rise and fall in its pale glow. It is the most familiar object in the night sky, yet it remains a place of mystery, carrying in its surface the scars of a violent past and the secrets of its birth. Without it, Earth would be very different, less stable, less predictable, and perhaps less alive. The moon is more than a satellite. It is a guardian, a clock, a reminder of cosmic history written in stone. The story of the moon's origin is as dramatic as any myth. The leading idea is the giant impact hypothesis, which suggests that long ago, a Mars-sized body struck the young Earth with catastrophic force. The collision blasted molten rock and vapor into orbit, a fiery ring of debris that slowly gathered and cooled into the moon we see today. If this is true, then the moon is not only Earth's companion but also its child, born from the same rock and metal that make up our world. It carries Earth's material in its bones, yet it formed as its own sphere, separate but forever tied by gravity. This shared birth explains why the moon is so closely bound to us, its fate locked to ours since the earliest days of the solar system. Over time, the moon settled into its place, turning in such a way that we see only one face. Its rotation is synchronized with its orbit, a dance of perfect balance known as tidal locking. This is why the far side of the moon remained unseen until spacecraft revealed it in the 20th century. To the naked eye, the moon never changes its gaze. We live under the same familiar pattern of craters and plains, the face that inspired countless myths and stories. But the far side is different, rugged and heavily cratered, a landscape untouched by the vast dark plains that mark the near side. It is as though the moon carries two personalities, one always visible and one hidden, patient but mysterious. Its phases mark the passage of time, a slow rhythm of waxing and waning that has guided calendars, rituals, and agriculture for millennia. The crescent rising in the west, the full moon glowing at midnight, the shadowed sliver before dawn. All of these cycles connect human life to cosmic motion. Each phase is the result of sunlight falling at different angles on the moon as it orbits Earth. The changing light is simple geometry, yet it feels like poetry written across the sky. To watch the moon's phases is to see time made visible, to feel the Earth and moon and sun aligned in a slow turning dance. The moon's pull on Earth is invisible yet immense. Its gravity raises tides, drawing oceans into bulges that sweep around the globe as the planet turns. This constant motion stirs the seas, redistributes heat, and shapes coastlines. Without the moon, tides would be faint whispers compared to the dramatic surges we know. The rhythm of the tides has guided life for eons, from the earliest organisms that followed the rise and fall of shallow seas to the migrations of modern creatures. Even human societies have long been tied to the ebb and flow, watching the moon's phases to predict when waters would rise and recede. The moon is a clock of the oceans, ticking steadily with every orbit. During eclipses, the relationship between Earth, moon, and sun becomes starkly visible. A solar eclipse, when the moon passes in front of the sun, turns day into night in a fleeting moment of wonder. A lunar eclipse, when Earth's shadow falls across the moon, paints it red as sunlight bends through the atmosphere and scatters. These events remind us that celestial alignments are not abstract ideas but lived experiences, shadows and lights cast across our world. The moon's size and distance make these eclipses possible. By a strange coincidence, it appears almost exactly the same size as the sun in our sky, allowing it to cover the solar disk perfectly. No other world we know has such a pairing. It is a cosmic quirk that grants us moments of awe. The moon's surface is a museum of impact craters, frozen in time because there is no atmosphere or weather to erode them away. Some are small, shallow pockmarks. Others are vast basins, hundreds of kilometers across, created by collisions with asteroids billions of years ago. These scars tell the story of a violent early solar system when debris still roamed freely. Where Earth's surface has shifted and renewed itself through tectonics and erosion, the moon preserves its history like a library of stone. To look at the craters is to look into deep time, to see a record untouched by wind or rain. The dark plains we call Maria, Latin for seas, are not oceans but ancient lava flows. Long ago, the moon's interior was active, and molten rock poured out across vast regions, filling craters and basins with smooth basalt. When seen from Earth, these areas appear as dark shapes, forming patterns that once inspired legends of rabbits, faces, and gods. The Maria are younger than the highlands, less scarred by impacts, yet still ancient compared to life on Earth. They are the remnants of a time when the moon was restless, before its interior cooled and quieted. Now it is geologically silent, a still world circling a living one. On the far side, the landscape is harsher, dominated by craters and highlands. The lack of Maria there remains a puzzle, perhaps linked to differences in crust thickness or past heating events. Whatever the reason, the far side feels alien even compared to the familiar face we know. It was a secret kept until humanity sent probes to orbit, and its revelation showed us that even the most constant companion can hold hidden sides. The moon also acts as a stabilizer for Earth's tilt. Without it, the planet's axis might wobble chaotically under the pull of other worlds and the sun. This stability has kept Earth's climate relatively steady over millions of years, allowing life to flourish. Seasons come and go, but they do not swing wildly, and the moon's steadying presence is one of the reasons why. It is a quiet protection, unseen but profound. For all its silence, the moon has always spoken to human imagination. Poets and dreamers have looked up at its light, seeing guidance, mystery, or love reflected in its glow. Travelers have followed it across deserts and seas. Children still gaze at it with wonder, the same way their ancestors did thousands of years ago. And for a brief moment in history, humans walked upon its surface, leaving footprints in dust untouched for billions of years. Those prints remain today, silent reminders of when Earth reached out to its companion. The moon is not just a rock in the sky. It is a keeper of time, a guardian of tides, a witness to Earth's story. It glows not with its own light, but with sunlight reflected across space, a gentle lantern reminding us of our place in the cosmos. Night after night, it rises and sets, unwavering, faithful, and calm. In its silence, it keeps watch. In its presence, it steadies us. The moon is Earth's patient companion, circling endlessly, guarding quietly, a reminder that even in the vastness of space, we are not alone. In the quiet darkness of the solar system, Mars glows like a faint ember, a rust-red spark against the backdrop of black. It is smaller than Earth, colder and thinner in breath, yet it draws our imagination more than almost any other world. The ancients named it for the god of war, its color reminiscent of blood and fire. For centuries, we have looked toward it with wonder and unease, imagining civilizations, canals, and deserts stretching beneath its pale sky. Today, with spacecraft and rovers tracing its surface, Mars is no longer just a symbol in the night sky. It is a frontier, both barren and beautiful, whispering stories of what might have been and what could one day be. The surface of Mars carries the ghost of water. Winding across its plains are riverbeds that no longer flow, valleys carved by torrents long vanished, and deltas that stand as fossilized memories of lakes that once shimmered in the sunlight. Dry channels stretch for hundreds of kilometers, their patterns unmistakably shaped by liquid coursing downhill. In craters, minerals reveal they were once bathed in water, forming clays and salts that cannot appear in a dry world. At its poles, gleaming white caps of frozen carbon dioxide and water shift with the seasons, shrinking and swelling in cycles of frost and thaw. Though Mars today is arid and frigid, these features remind us of an ancient past when the planet may have been more alive, its surface warmer, its skies heavier with atmosphere, its lakes and seas sheltering possibilities for life. The atmosphere Mars clings to now is a fragile veil, less than 1% the thickness of Earth's. It offers little warmth and almost no protection. Sunlight passes easily through it, and so does the chill of space. Standing on Mars would feel strange. The sky tinted a pale butterscotch during the day, fading into deep twilight at dusk. Yet the thin air cannot hold heat, and temperatures swing violently, plunging far below freezing even as the sun shines overhead. At night, frost forms on rocks, and dust settles across the landscape like fine powder. The air is mostly carbon dioxide, toxic to us, but precious to machines that dream of transforming it, of drawing oxygen from the Martian breath as a step toward making it a home. Dust defines Mars as much as rock. Fine grains cover its surface, iron-rich and oxidized, giving the planet its distinctive red color. Winds whip this dust into colossal storms that can engulf entire regions, sometimes even the whole globe. When these tempests rise, the sky darkens for weeks, and the sun's light dwindles to a dim glow. Spacecraft have watched as storms circled the planet like slow, swirling oceans of sand, their edges shifting and curling as they move. Rovers on the ground have been buried in the haze, their panels coated in dust that blocks their energy. Yet these storms, though immense, are not violent in the way earthly hurricanes are. With the atmosphere so thin, the winds would barely ruffle clothing. It is not their force but their scale that astonishes, a reminder that Mars is shaped by time and air too sparse to feel yet powerful enough to sculpt. Volcanoes tower on Mars, like monuments to a fiery past. Olympus Mons, the largest volcano in the solar system, rises nearly 3 times the height of Mount Everest and sprawls across a region the size of a small country. Its slopes are so broad that standing on them, one might not even notice the incline. This volcano, along with others in the Tharsis region, speaks of a time when Mars was geologically restless, when magma surged from deep below, pouring across the surface in flows that built mountains higher and plains wider than almost anywhere else we know. Though now quiet, these giants remind us that Mars was not always still. The planet holds in its bones the memory of fire. Its 2 moons, Phobos and Deimos, are small and misshapen, more like captured asteroids than worlds of their own. Phobos orbits so close that it crosses the sky in just a few hours, a lumpy shadow racing above the red plains. Slowly, it is spiraling inward, doomed to one day crash into Mars or break apart into a ring of debris. Deimos, smaller and farther away, drifts more gently, circling Mars like a faint companion, quiet and unassuming. Together, these moons are reminders of the solar system's chaotic history, fragments of rock that found themselves bound to Mars, circling endlessly as witnesses to the planet's long story. What fascinates us most about Mars is not only what it was, but what it might still hold. If water once flowed there, could life have followed? Perhaps not in sprawling forests or oceans of creatures, but in microbial forms tucked into shallow lakes or underground aquifers. Even today, beneath its surface, briny reservoirs may remain, dark and shielded from radiation, places where life could survive in secret. Scientists search for chemical fingerprints, tiny whispers in the soil and air that might suggest biology still lingers. The idea of even the simplest life on Mars captures the imagination, because it would mean Earth is not unique, that life can spark wherever conditions are even briefly favorable. For humanity, Mars has always been more than a planet. It is a mirror of our ambitions. Rovers crawl its surface, drilling, photographing, listening, and sending back stories of dust and stone. Orbiters map its valleys and canyons with stunning precision. Each mission inches us closer to the possibility of walking there ourselves, of placing human footprints on the red soil. The thought of colonizing Mars, of building habitats beneath its sky, of carving out an existence where no life now thrives, is both daunting and exhilarating. It represents our urge to explore, to reach beyond what is known, and extend our fragile presence to another world. Mars is harsh, unforgiving, and empty. Yet it calls to us, because in its silence, it holds potential. It is close enough to imagine touching, alien enough to challenge us, and familiar enough to remind us of home. Its valleys whisper of rivers, its ice glimmers with promise, and its thin air speaks of possibility. Even as dust storms rage and temperatures plummet, we look at it and see not only what it is, but what it could mean for us. The red planet stands as a frontier not conquered, not claimed, but waiting. Waiting for answers to ancient questions, waiting for the first human voices to echo across its plains, waiting for the continuation of a story that began billions of years ago when it formed from fire and dust. Mars is a reminder that exploration is not only about reaching other worlds, but about understanding ourselves. The desire to set foot there is not simply curiosity. It is the deep human impulse to step into the unknown, to carry our fragile flame farther into the dark. Mars may never be a second Earth, but it does not need to be. It is its own place, stark and scarred, yet beautiful in its solitude. It is the red frontier, a world that carries in its soil the history of the solar system, and in our imagination, the dream of what lies ahead. Between Mars and Jupiter lies a realm of fragments, a scattered wilderness of stone and metal adrift in the sun's light. It is not a place of dense swarms, as old drawings once suggested, with ships dodging tumbling boulders at every turn. Instead, the asteroid belt stretches vast and thin, its objects separated by immense distances, silent travelers circling endlessly in a region that never quite became a world. It is a graveyard of beginnings, filled with remnants that could have grown into planets, but were left behind, fragments of creation frozen in time. To drift through it is to wander among ruins, an ancient archive of the solar system's youth. The story of the asteroid belt begins in the early days, when the solar system was still a swirling disk of gas and dust. Planets were forming, colliding, growing, drawing material into themselves with gravity's pull. But between Mars and Jupiter, something interrupted the process. The immense tug of Jupiter's gravity stirred the region too violently, scattering and shattering what tried to coalesce. Instead of a planet, a belt of fragments remained small worlds that never grew, locked forever in unfinished orbits. They are leftovers of a cosmic construction site, pieces of raw material that never became part of anything larger, preserved for billions of years. Among these fragments are a few giants of their kind. Ceres, the largest, is so massive it crosses the boundary between asteroid and dwarf planet. Nearly 1.0 kilometers wide, it holds a third of the belt's total mass. Its surface is scarred with craters and mysterious bright spots, reflective salts that may mark ancient cryovolcanoes or remnants of underground oceans. Ceres hints at a history more complex than bare rock, whispering of water and hidden activity beneath its quiet exterior. Vesta, smaller but still mighty, reveals another tale. Its surface is covered in basalt plains, evidence of ancient lava flows that hardened into stone. At its southern pole, an enormous impact crater exposes layers deep within, a scar so vast that fragments blasted from it have traveled across space and landed on Earth as meteorites. When we hold pieces of these meteorites in our hands, We are holding shards of Vesta itself, torn free in a violent instant, but carrying its history across the void. Most asteroids are far smaller, ranging from mountains to pebbles, each one a world in miniature. Some are jagged rubble piles, barely held together by gravity after countless collisions. Others are solid metal, gleaming with iron and nickel, relics of ancient cores from bodies shattered long ago. They come in shades of dark carbon, bright silicate, or reflective metal, each composition telling a story about where they formed and what they endured. Their surfaces are battered, their shapes irregular, their orbits long and patient. Each asteroid is a survivor, carrying the record of billions of years of impacts, heating, and motion, unchanged by atmosphere or weather. In their stillness, they are honest, unpolished fragments of what the solar system once was. Collisions are the heartbeat of the belt, slow but relentless. Over time, asteroids strike one another, breaking apart, scattering debris that sometimes drifts inward toward Earth. These fragments become meteorites, the small messengers that fall through our sky in streaks of fire before cooling as stones on the ground. Some meteorites are older than Earth itself, containing minerals that condensed in the first moments after the sun ignited. They are records of conditions we can no longer witness, fossils of a time before planets existed. Holding one is like holding a page torn from the solar system's earliest chapter. Others carry organic molecules, carbon compounds that may have played a role in seeding life on Earth. In this way, the belt is not only a scarred archive but a silent benefactor, its fragments carrying the seeds of complexity across space. The asteroid belt is not a uniform ring but a dynamic, textured place. Within it, resonances with Jupiter carve gaps known as Kirkwood gaps, regions where orbits are unstable and objects are gradually cleared away. Over time, the belt has been sculpted by gravity, its population redistributed, thinned, and reshaped. What remains is only a fraction of what once was. Long ago, there may have been 10 times as much material here, but collisions and planetary interactions sent much of it spiraling away. What is left is the residue, the survivors, the fraction that endured the chaos of formation. Though it seems distant and quiet, the belt is intimately connected to Earth. The rocks that strike our planet, sometimes harmless, sometimes catastrophic, often come from this region. The event that ended the age of the dinosaurs 65 million years ago was likely triggered by an asteroid displaced from its orbit, sent hurtling inward until it met Earth in a fiery collision. Such impacts are rare on human timescales but inevitable over geological ages. In this sense, the belt is both archive and threat, a reminder that creation and destruction are never far apart in the solar system's story. Yet not all of its fragments are hostile. Many may one day become resources. Rich in metals, water ice, and carbon, the belt holds vast supplies of material that future explorers may mine to build and sustain new ventures beyond Earth. To harvest from it would be to turn ruins into foundations, to use the debris of aborted worlds as stepping stones to new ones. It transforms from archive to opportunity, not only a scar but a bridge. Still, there is something profoundly moving about the belt as it is. To imagine drifting among its scattered stones is to wander through time. Every crater, every fractured surface, every tumbling block carries a memory of an impact, a collision, a moment in the deep past. The silence of these worlds is not emptiness, but accumulation layer upon layer of cosmic history preserved in raw, unweathered form. Unlike Earth, where wind and water erase and remake landscapes, the belt has no such forces. Its scars endure, unchanged for eons. When we look at the asteroid belt, we are not seeing chaos, but the persistence of fragments. The pieces that remain tell us that the solar system is not only a place of finished worlds, but also of incomplete ones. They remind us that creation does not always arrive at completion, that sometimes what is left undone can still hold beauty and meaning. The belt is a scar across the solar system, but scars are stories, and stories are what allow us to remember. And so the asteroid belt drifts, circling quietly between Mars and Jupiter, a wide expanse of relics that never became a single world. It is not an empty failure, but a preserved archive, a reminder that the history of our system is one of both triumph and interruption. In its stones lie the whispers of beginnings, collisions, and possibilities. It is the solar system's memory made visible, etched not in books or voices, but in craters, fragments, and silent orbits. A scarred archive, waiting for us to listen. Jupiter looms like a monarch at the heart of the outer solar system, a world so immense that all the other planets together could fit inside it and still leave room to spare. It is a giant of gas and storm, a sphere striped with bands of ochre, cream, and rust, wrapped in swirling winds that race faster than any hurricane on Earth. Seen through a telescope, Jupiter is mesmerizing, a living canvas of motion and turbulence, where storms the size of continents rage for centuries. To drift near it would be to confront scale itself, to feel the presence of a planet not built of rock and soil, but of pressure, fluid, and gravity on a scale too vast for Earth to imitate. Jupiter is not simply a planet, it is the solar system's elder king. The gas giant is the fifth planet from the Sun, orbiting far beyond the rocky inner worlds, and its size and mass shape the system around it. Its gravity is immense, reaching out across millions of kilometers, tugging at asteroids, comets, and even the orbits of neighboring planets. Without Jupiter, Earth's history might have been very different. The giant's pull has drawn in countless icy wanderers from the outer reaches, deflecting many and swallowing others, reducing the number of catastrophic impacts that might otherwise have scarred our world beyond repair. It is both guardian and disruptor, a protector that absorbs chaos yet also sends fragments hurtling inward, a cosmic bouncer at the edge of our fragile neighborhood. Its influence is woven into the story of Earth's survival. Jupiter is made not of solid ground but of layers of gas compressed under its own enormous weight. Hydrogen and helium, the same elements that fuel the Sun, form the bulk of its body. As one descends into its depths, the gas thickens into liquid, and deep within, the pressure becomes so intense that hydrogen itself transforms into a strange metallic form, conducting electricity and generating one of the most powerful magnetic fields in the solar system. This invisible shield stretches millions of kilometers into space, trapping particles, sculpting auroras, and creating an environment around Jupiter that is more hostile than almost anywhere else we know. Its magnetic field dwarfs Earth's, a reminder that Jupiter is not just large in appearance but in invisible presence as well. The face of Jupiter is its atmosphere, and it is alive with storms. The most famous of these is the Great Red Spot, a colossal tempest larger than our entire planet, spinning for at least 4 centuries, perhaps longer. It is a storm with no land to slow it, fueled endlessly by the planet's heat and energy. Around it, bands of cloud streak in parallel, flowing east and west at hundreds of kilometers per hour, colliding at their borders to form turbulence and eddies. New storms arise constantly, white ovals, brown barges, dark patches, each one a reminder that this planet is restless, its skies a cauldron of motion without pause. To gaze at Jupiter is to see weather unchained, storms not measured in days but in generations. Jupiter does not stand alone. It is a miniature solar system in itself, orbited by dozens of moons, each with its own story, each a world that could be studied for lifetimes. The 4 largest, discovered by Galileo over 400 years ago, are worlds that rival planets in size and character. Io, closest to Jupiter, is a volcanic inferno, its surface constantly reshaped by eruptions that spew sulfur into space. It is the most geologically active world we know, a tortured sphere kept alive by Jupiter's tidal pull, stretching and squeezing it until its insides churn with heat. Europa, a bright icy moon, appears still and frozen on its surface, but beneath its crust of ice lies a vast ocean of liquid water kept warm by the same tidal forces. It is one of the most promising places to search for life beyond Earth, a hidden sea sheltered in darkness. Ganymede, larger than Mercury, is the biggest moon in the solar system, a world with its own magnetic field, something no other moon can claim. Its surface is a mix of bright ice and darker, older terrain, carved with ridges and grooves that hint at a complex history of shifting and stretching. Callisto, the outermost of the Galilean moons, is ancient and cratered, its surface a record of impacts stretching back to the dawn of the solar system. These four moons orbit in a delicate dance, their motions locked together by gravity, tugging on each other in rhythms that remain steady over eons. To watch them is to see miniature planets circling their giant parent, each telling a different version of what a world can be. But the Galilean moons are only part of Jupiter's family. Dozens of smaller moons orbit farther out, irregular and captured, fragments pulled into its embrace over billions of years. Together they form a court around the king, a retinue of bodies that testify to Jupiter's reach. It gathers companions as easily as it bends comets, holding them in orbits that circle endlessly, like witnesses to the planet's long reign. Though we cannot land on Jupiter, its presence is felt throughout the solar system. Its storms roar with energy. Its magnetism hums across space. Its moons promise oceans and volcanoes. And its gravity shapes the paths of countless smaller worlds. To imagine standing near it is impossible, for there is no solid ground, no horizon. One would sink endlessly into cloud and pressure until crushed. Jupiter is not a place one visits. It is a presence one beholds. In myth and in science, Jupiter has always been a figure of dominance, its mass commanding, its appearance mesmerizing. Yet it is also a reminder of balance. It shields and threatens, creates and destroys, holds moons that are fiery and icy, ancient and alive. It is both king and servant, protector of Earth yet shaper of chaos, a paradox written in bands of storm and shadow. Jupiter's vastness humbles us. It reminds us that Earth, so rich with life, is small against the scale of giants. And yet, without this elder king, our story might not have unfolded as it has. Jupiter's presence is not only visible in the night sky, shining bright as one of the most radiant points of light, but also hidden in the story of every impact we avoided, every fragment diverted, every chance life was given to flourish on our world. To look at Jupiter is to see more than a planet. It is to witness the solar system's balance of chaos and order embodied in one colossal sphere. The Elder King continues his reign, swirling endlessly beneath the sun, his storms still raging, his moon still circling, his influence still stretching across the dark. Saturn drifts in the outer reaches of the solar system, like a dream caught in orbit. A planet so beautiful, it seems painted rather than real. Its rings shimmer like spun glass, delicate and vast, encircling the golden globe in bands of ice and dust. Through even a modest telescope, Saturn feels unreal, a jewel floating in the dark, too elegant to belong to the same universe that shaped scarred craters and raging storms. Yet Saturn is not fragile. It is immense, second only to Jupiter in size, a gas giant whose gravity commands a family of moons and whose presence influences the solar system at large. It is both a work of art and a machine of physics, a paradox of elegance and power. The rings are Saturn's signature, wide enough to stretch nearly 300 kilometers from edge to edge, yet so thin that in most places they are barely a kilometer thick. They are made not of solid sheets, but of countless fragments, each piece ranging from tiny grains of ice to boulders the size of mountains, all orbiting together in an endless ballet. From afar they appear continuous, like solid ribbons, but up close, they are a swirling storm of particles, colliding and scattering light. Sunlight reflects off their icy surfaces, making them glow with a pale brilliance against the black of space. The rings are divided into broad bands: the A ring, the B ring, the faint C ring, and between them lie gaps, carved by the gravity of Saturn's moons, shepherds that hold the structures in place. These moons stir the particles, shaping arcs, braids, and ripples, patterns that appear as if an unseen hand were sculpting lines into dust and light. Despite their grandeur, the rings are not permanent. Astronomers believe they may be relatively young, perhaps only 100 million years old, born from shattered moons or comets that strayed too close and were torn apart by Saturn's gravity. Even now they are fading, particles falling into Saturn's atmosphere in a slow rain of ice. One day, millions of years from now, they may vanish entirely, leaving Saturn bare, its jewel-like adornment only a memory. That ephemerality makes them more precious, a fleeting moment of beauty in the long history of a giant planet. Beneath the rings lies Saturn itself, a world of gases layered in clouds of ammonia and hydrogen. Its bands are subtler than Jupiter's, softer in hue, pale golds and muted creams stretched into stripes by fierce winds that can reach speeds faster than any hurricane on Earth. Saturn is less dense than water, its bulk so spread out that if it could be placed in a cosmic ocean, it would float. Yet this lightness hides storms of unimaginable scale. At its north pole swirls the Great Hexagon, a six-sided jet stream larger than Earth itself, a shape that has endured for decades, perhaps centuries, spinning like a wheel at the planet's crown. Storms erupt and fade across its surface, some so vast they encircle the entire planet, leaving scars in the clouds that last for years. Saturn may look serene from a distance, but it is restless, its beauty shaped by motion. Saturn's magnetic field adds another invisible layer of presence. Though weaker than Jupiter's, it still creates auroras at the poles, glowing ovals of light, where charged particles stream along invisible lines and crash into the upper atmosphere. These magnetic fields shape the environment around Saturn, influencing its rings and its moons, filling its neighborhood with radiation and currents of charged gas. The elegance of Saturn is not only visible in its rings, but in these unseen forces, patterns of magnetism woven silently around the planet. Yet Saturn's moons may be its most remarkable gift. Among them, Titan stands apart as a world almost planetary in scale, larger than Mercury, cloaked in a thick orange atmosphere. It is the only moon in the solar system with a substantial atmosphere, denser even than Earth's, and within it lies a landscape both alien and familiar. Methane and ethane rain from orange skies, carving rivers and pooling into lakes. Dunes ripple across its surface, and beneath its icy crust, scientists suspect a deep ocean of water mixed with ammonia, a hidden sea that could harbor conditions for life. Titan is not just a moon but a laboratory of chemistry, a place where Earth-like processes play out with different materials, a mirror turned strange and beautiful. Another of Saturn's moons, Enceladus, is far smaller, yet it may hold secrets even more profound. This tiny, gleaming sphere is covered in ice, and from cracks at its south pole erupt geysers of water vapor and icy particles that shoot hundreds of kilometers into space. These plumes contain organic molecules and salts, evidence of a salty ocean hidden beneath the frozen crust. It is a world where warmth, water, and chemistry coexist, and where life, if it exists beyond Earth, might find a home. The geysers feed one of Saturn's rings, scattering material outward, making Enceladus not just a world of its own, but a contributor to the planet's elegance, weaving its water into the fabric of Saturn's halo. Dozens more moons orbit Saturn, each unique. Mimas, scarred with a giant crater that makes it resemble a watchful eye. Iapetus, with one hemisphere dark as coal and the other bright as snow, a yin and yang drifting in the dark. Rhea, Dione, Tethys, Hyperion. Each carries its own marks of craters, fractures, and history. Together they form a family, a court surrounding their jewel-like master, each moon adding depth to the story of Saturn. Saturn is not only a sight to behold through telescopes, but also a world that whispers to us of impermanence and possibility. Its rings remind us that beauty can be fragile and fleeting, an adornment destined to fade. Its moons remind us that oceans may exist in places where sunlight never reaches, that life's potential is not confined to Earth's temperate surface. Its storms remind us that elegance often hides turmoil, that serenity can be shaped by chaos. To drift in Saturn's presence would be to witness grace and grandeur entwined, a planet wrapped in shimmering light, encircled by companions both fiery and frozen. It is not only the ringed jewel of the solar system, but also a reminder that even in the cold outer dark, beauty flourishes, delicate yet vast, patient yet impermanent. Saturn turns slowly on its path around the sun, its rings scattering sunlight like crystal dust, its moons circling in endless devotion. And we, far away on Earth, look toward it with wonder, seeing in its elegance both a mystery and a promise. Uranus drifts on the edge of perception, pale and ghostly, a turquoise world tilted so far on its side that it seems to roll through its orbit rather than spin. While most planets stand upright in space, their poles angled modestly, Uranus is a dreamlike exception, tipped at nearly 98 degrees. Its north and south poles point almost directly toward the sun during parts of its long journey, leaving one hemisphere in continuous daylight for decades, while the other lingers in shadow. Seasons here are not like those on Earth. They are extreme, drawn out, and surreal. A single year on Uranus lasts 84 Earth years, meaning that a person born during one season might live their entire life before seeing the return of that season again. This tilt is no small quirk. It is a profound mystery, one that hints at violence long ago, perhaps a collision with a massive body that knocked Uranus askew and left it rolling like a wounded dreamer through the dark. Its sideways spin creates a planet that feels uncanny. Day and night lose their rhythm, and the familiar patterns of sunlight are replaced by strange cycles of endless brightness and endless dark. The atmosphere, tinted by methane that absorbs red light and leaves behind soft hues of blue and green, reflects a cool serenity, as though the planet itself wears a veil of frost and quiet. Beneath this delicate outer layer lies an icy mantle, a mix of water, ammonia, and methane ices compressed into exotic forms by immense pressure. Uranus is not a gas giant like Jupiter or Saturn, but an ice giant, smaller, denser, and stranger. A planet where chemistry and physics create states of matter not found on Earth. The winds here are swift, despite the planet's calm appearance. In its upper atmosphere, storms swirl quietly, bands of clouds moving at hundreds of kilometers per hour. Most are faint, hidden beneath the planet's pale mask, but when they erupt, they appear as bright white patches against the turquoise backdrop. These storms are powered not by internal heat, as on Jupiter and Saturn, for Uranus emits surprisingly little warmth, but by the complex interplay of sunlight, tilted seasons, and atmospheric currents. The result is a planet that looks still from afar, but is alive with hidden motion, its elegance masking its restless heart. Encircling Uranus are rings, faint and dark, less grand than Saturn's but no less strange. They are narrow, thin bands of particles made mostly of dark rock and dust, so dim they were invisible until the late 20th century, when they were discovered almost by accident. These rings are uneven, broken into arcs and clumps by the pull of small shepherd moons that guide their shapes. Though subtle, they whisper of Uranus's history, perhaps the remnants of shattered moons or the debris of captured bodies. Against the planet's pale glow, the rings are like charcoal lines drawn across turquoise glass, understated but unmistakable. The moons of Uranus add to its dreamlike quality. Unlike Jupiter's or Saturn's vast collections, Uranus's moons feel like characters in a myth, each named after spirits from Shakespeare and Alexander Pope. Miranda, Ariel, Umbriel, Titania, Oberon. They orbit sideways with their parent, their paths tilted and strange. Miranda is scarred with canyons and cliffs that tower higher than any on Earth, as if its surface were torn apart and stitched back together. Titania and Oberon, larger and darker, show the marks of ancient impacts, reminders of the solar system's violent past. These moons are small, cold and quiet, but their surfaces are etched with stories, fragments of the chaos that once shaped them. Even the planet's magnetic field refuses to conform. Unlike Earth's, which is neatly aligned with its axis, Uranus's magnetic field is wildly off-center, tilted more than 50 degrees and shifted away from the planet's core. This creates a lopsided, shifting magnetosphere that wobbles and twists as Uranus turns, a field that bends and flares unpredictably. Charged particles spiral along these skewed lines, generating auroras that flicker strangely across its poles, though not where one might expect them to be. The entire system feels unmoored from symmetry, as though Uranus delights in defying order. It is easy to imagine Uranus as the solar system's dreamer, drifting sideways through space, wrapped in a turquoise haze, accompanied by faint rings and moons with names pulled from poetry. It is a world that does not fit the neat categories of its neighbors. Its tilt challenges the sense of balance. Its faint storms challenge the notion of stillness. Its faint glow of heat challenges the rules we thought applied to giants. Uranus is a planet that asks us to reconsider what is normal, what is expected, and what is possible. Long ago, when Voyager 2 flew past in 1986, it offered humanity its first close view of this tilted enigma. The images it sent back revealed a bland, pale world, with little of the dramatic storms of Jupiter or the vivid rings of Saturn. For decades, Uranus seemed quiet, almost boring, an afterthought at the edge of the solar system. Yet with time and new observations, its hidden complexities have emerged. Subtle storms erupt. Rings shimmer faintly in infrared light. Magnetic fields twist and shift with startling irregularity. Beneath its pale mask lies a planet as strange and dynamic as any other, a world that refuses to be dismissed. Uranus reminds us that even in the orderly dance of planets, there are outliers, worlds that defy symmetry and predictability. Its tilted spin, its faint rings, its moons with fractured faces all tell of a history written in upheaval. It is a planet caught between elegance and oddity, its presence in the solar system, like a dream, half-remembered, elusive and strange. To drift past it would be to enter a place where day and night blur, where seasons last lifetimes, and where even the rules of magnetism bend sideways. And so Uranus rolls along its path, patient and peculiar, turning on its side through the dark. It carries with it a quiet defiance, an insistence that not all worlds must stand upright, that even in the vast order of the solar system, there is room for the dreamers, the tilted mysteries, the planets that remind us that the universe does not conform to expectation. It drifts like a turquoise lantern at the edge of sight, a reminder that beauty can be strange, and strangeness can be beautiful. Neptune waits at the far frontier, the last great planet of our solar family, a sapphire world cloaked in deep blue and hidden beneath a veil of storms. It is a place of distance and quiet, so far from the sun that light takes more than 4 hours to reach it. And yet within its atmosphere lies a violence unmatched anywhere else in the system. Winds race faster than the speed of sound, roaring across the planet's cold skies at over 20 kilometers per hour. They twist and coil into immense tempests, including vast dark storms that appear and vanish like shifting shadows. From afar, Neptune looks serene, a tranquil jewel on the edge of night. But up close, it is a restless world, turbulent and untamed, its atmosphere a ceaseless ocean of motion. This giant, though smaller than Jupiter and Saturn, is still immense compared to Earth, nearly 4 times our planet's diameter. Its mass contains more than 17 Earths, composed of hydrogen, helium, and traces of methane that give it its iconic azure hue. Methane's grip on red light leaves Neptune dressed in a blue, so vivid it seems to glow from within. But beneath that calm facade lies an icy mantle of water, ammonia, and methane compressed into exotic states, wrapped around a small rocky core. It is a place where chemistry bends under pressure, where matter takes forms unfamiliar to human experience. Neptune's storms, like great spiraling wounds, are fierce but fleeting. Unlike Jupiter's great red spot, which has endured for centuries, Neptune's great dark spots come and go within a few years, born out of turbulent winds and dissipated back into the deep. These storms are so vast they could swallow Earth whole, yet they appear like transient phantoms, reminders that even on a planetary scale, nothing lasts forever. Around them, bright white clouds made of methane ice crystals swirl like wisps of breath on a winter morning, drifting across the blue canvas of the planet below. The storms seem to whisper of hidden energy, of a restless heart beneath a frozen shell. For Neptune, distance from the sun does not mean stillness. Though it receives only a fraction of the sunlight Earth does, it radiates far more heat into space than it takes in, as if its interior holds a fire left over from its birth. That inner energy powers the ferocious winds, stirring the atmosphere into motion and sustaining tempests that rage through the dark. Here, the cold is extreme, yet paradoxically, the planet is alive with movement. It is a reminder that quietness is not always calm, that stillness is not always empty. Even on the frozen edge, there can be fury. Encircling Neptune are rings, faint and fragile, arcs of dust and ice grains that cling to its orbit like delicate brushstrokes. They are not the wide, shimmering bands of Saturn, but broken, incomplete structures, scattered and dim. Some appear as clumps or arcs, rather than continuous circles, held together by the gravitational pull of tiny shepherd moons. These rings, fragile as smoke, tell of collisions and captures, the debris of a system shaped by chance and time. Against the darkness of space, they barely shimmer, faint echoes of a world in motion. Neptune's moons orbit in strange and varied paths, but none is more haunting than Triton. Larger than Pluto, Triton circles Neptune not in harmony, but against the current, its orbit retrograde, moving opposite to the planet's rotation. This unnatural path suggests it was not born here but captured long ago, a wandering body pulled in and held fast by Neptune's gravity. Triton is no ordinary moon. Its surface, pale and fractured, is marked by frozen plains and geysers that spout plumes of nitrogen gas high into the thin atmosphere, dark streaks stretching across the icy ground. It is a world that breathes faintly in the cold, where frozen nitrogen melts just enough under sunlight to burst skyward before falling back like snow. Triton is alive, not with life, but with motion, a reminder that even on the frozen outskirts of the solar system, worlds are not dead, but dynamic. The capture of Triton may have been violent, an event that altered Neptune's history. Such an enormous moon arriving from beyond could have destabilized earlier companions, scattering them or shattering them into fragments. What remains is a solitary dominion. Neptune and Triton locked together in their strange dance, a planet and its moon bound by gravity yet moving in opposition. Over billions of years, tidal forces will continue their quiet struggle, and Triton will spiral ever closer until it shatters, forming a ring brighter than Saturn's before finally succumbing to the planet below. The future of Neptune is written in slow inevitabilities, a tale of orbits and tides stretched across eons. Voyager 2 was the only spacecraft to pass this far, gliding by Neptune in 1989. Its cameras captured the first close glimpses of the Great Dark Spot and Triton's erupting geysers, freezing them in memory before they faded into history. Since then, no spacecraft has returned, and Neptune remains the least explored of the giant planets, a world glimpsed briefly and then left alone. Yet even from Earth, telescopes continue to reveal its shifting clouds, its changing storms, its restless nature. Neptune keeps its mysteries, showing just enough to remind us that the solar system's edge is not silent but alive. It is fitting that Neptune, named for the Roman god of the sea, should embody such contradictions. A world of deep blue, calm in appearance but raging within. A planet of cold distance, yet a forge of furious winds. A giant wrapped in faint rings and trailed by a captured moon that rebels against its spin. It is the ocean of the outer solar system, vast and unknowable. Its surface serene, its depths restless. At the farthest edge, Neptune reminds us that the solar system is not a closed, quiet place, but a living, moving, changing system. Its winds speak of hidden power. Its storms speak of impermanence. Its moon speaks of capture and change. To look upon it is to see the restless edge of our cosmic neighborhood, a place where distance breeds strangeness, and strangeness reveals beauty. Neptune drifts in its wide, cold orbit, the final great planet, glowing softly in the dark. Around it, storms rise and fade, winds howl silently faster than sound, rings shimmer faintly, and Triton circles backward with quiet defiance. It is a world that resists stillness, a reminder that even in the farthest reaches, motion endures. At the edge of night, Neptune waits, restless, beautiful, and strange. On the outer edge of the solar system, beyond the path of Neptune, lies a realm of small but remarkable worlds. Here, sunlight arrives as a pale echo, so weak that noon resembles twilight. And yet within this cold darkness, entire landscapes rise and fall. Pluto, once the 9th planet, now wears the title of Dwarf planet, but its story is far greater than its classification. Discovered in 1930, it spent most of the 20th century as the outer sentinel of our planetary family, until new discoveries forced astronomers to redraw the map. Its demotion was not a loss of importance, but a recognition that Pluto was not alone. It was one of many, a member of a hidden kingdom of icy bodies orbiting in the Kuiper belt. When spacecraft finally reached Pluto in 2015, what it revealed was a world far more alive than anyone expected. Its surface gleams with ice mountains taller than the Rockies, valleys carved by ancient flows, and plains that stretch like frozen seas. At its heart lies a vast region shaped like a great pale heart, a plain of nitrogen ice called Sputnik Planitia. This frozen expanse is not static. It churns and shifts as convection stirs the ice below, creating cell-like patterns that move over time. Even in the deep cold, Pluto is restless, its surface reshaped by forces hidden beneath. From orbit, the heart seems like a message written across the planet, a reminder that even small worlds can hold profound beauty. Pluto is smaller than Earth's moon, yet it has an atmosphere that breathes with the sun's touch. When sunlight warms its surface, frozen nitrogen and methane sublimate into a thin haze that rises above the ground. Blue skies arch faintly above icy plains, layers of haze scattering the dim light, painting Pluto's air with delicate bands. When the sun sets, that same atmosphere can collapse, freezing back onto the surface, only to rise again with the next thaw. It is a fragile balance, a rhythm of presence and absence, as if Pluto inhales and exhales across the centuries. Orbiting beside Pluto is Charon, its largest moon, so large that the two bodies form a binary system, locked together in a gravitational embrace. They orbit a shared point in space, spinning always with the same face toward one another. Charon's surface is scarred and strange, with a vast canyon that dwarfs the Grand Canyon and a reddish cap at its pole, stained by gases drifting from Pluto and transformed by sunlight. Together, Pluto and Charon move as partners, each shaping the other, a duet drifting at the edge of the sun's reach. Beyond Pluto, the dwarf planets Eris, Haumea, and Makemake add their own stories to this frozen frontier. Eris, discovered in 2005, is nearly the same size as Pluto, but more massive. And its discovery was the spark that led astronomers to redefine what it means to be a planet. Eris orbits far out in the scattered disk, a region even more distant and elongated than the Kuiper belt, taking centuries to complete a single path around the Sun. Its existence was a reminder that Pluto was not unique, that the solar system holds more worlds than once imagined. Haumea spins so rapidly that its body has been stretched into an elongated shape, like an egg or a flattened sphere, its day lasting less than 4 hours. It is encircled by a faint ring and has moons of its own, making it a miniature system with a strange rhythm, a world where rotation bends, form, and gravity carves something unexpected. Makemake, smaller than Pluto but still formidable, reflects the sun's light from a surface coated in methane ice, glowing faintly in the dark. These worlds are not merely leftovers or fragments. They are laboratories of possibility, each holding secrets of the solar system's youth, preserved in ice and shadow. Closer to home, within the asteroid belt, lies Ceres, the smallest dwarf planet but the first to be discovered. Once thought of simply as the largest asteroid, Ceres revealed itself to be more. Its surface shows bright spots of salt deposits, shining like lighthouses across its dark terrain, formed by briny water seeping up from below and evaporating in the vacuum of space. These brilliant patches suggest that Ceres still has liquid hidden deep within, reservoirs of water locked beneath its crust. In its own quiet way, Ceres bridges the inner solar system and the outer, a frozen world orbiting among rocky fragments, reminding us that even within familiar regions, strangeness endures. All of these dwarf planets are bound together by the Kuiper belt, a vast ring of icy bodies that stretches beyond Neptune, filled with billions of small frozen remnants from the solar system's formation. These are the building blocks that never became planets, pieces of ancient material preserved in deep freeze. From time to time, some are nudged inward, becoming comets that sweep past Earth with glowing tails, carrying with them the chemistry of the solar system's beginnings. Beyond the Kuiper belt lies the scattered disk, a realm of more distant and irregular orbits. Worlds like Eris wandering on paths tilted and stretched, caught in a gravitational dance with Neptune. Together, these regions form a borderland, a place where the sun's influence weakens but does not end, where icy worlds drift in long, patient orbits. They are not grand in size compared to Jupiter or Saturn, but their stories are immense. They tell us about the solar system's early chaos, about collisions and captures, about the material that built planets and the fragments left behind. They remind us that small does not mean unimportant. In their surfaces of ice and rock, in their tilted orbits and fragile atmospheres, lies the memory of creation itself. To think of Pluto, Eris, Haumea, Makemake, and Ceres is to think of persistence. These are worlds that linger at the margins, overlooked for decades, then revealed as essential pieces of the larger puzzle. They are survivors of a time when the solar system was young and violent, when planets grew by consuming, and countless smaller bodies were scattered outward. Some became moons, some shattered into asteroids, but others endured, quiet and unchanged, waiting at the edge for us to find them. Though distant, these dwarf planets offer us perspective. They show that the solar system is not a neat arrangement of 8 planets alone, but a sprawling, diverse collection of worlds, each with its own rhythm, its own beauty, its own tale. Some bear mountains of ice, others spin too fast to stay round, others carry bright scars of salt, and still others breathe thin, temporary atmospheres into the void. Together they form a chorus of strangeness, small voices carrying big truths. And so, at the edge of the sun's dominion, the dwarf planets remind us that size does not define wonder. They may be tiny compared to giants, but within their frozen plains and tilted orbits lies the story of how our solar system came to be. To drift among them is to wander through memory itself, a scarred and beautiful archive of the solar system's youth, each world a page in a book still being read. Far beyond the known planets, in regions where the sun's light fades into near darkness, lie the birthplaces of some of the most haunting travelers in the solar system. Comets, the wanderers of deep time, emerge from these frozen frontiers, carrying within them the untouched material of the cosmos as it once was. For billions of years, they have drifted silently in the Oort cloud and the Kuiper belt, waiting until the subtle pull of gravity nudges them inward. When they awaken, they become something entirely new, icy relics that suddenly breathe, glowing and unfurling tails of dust and gas across the night sky. They are both ancient and fleeting, appearing without warning, then vanishing for centuries, leaving behind only stories whispered in their absence. At their core, comets are small and unassuming. Their nuclei are little more than chunks of rock, dust, and ice, dark and inert as they slumber in the cold. Yet when they approach the sun, heat transforms them. Ices locked in their depths vaporize, escaping as jets of gas that carry with them trails of dust. Around the nucleus forms a coma, a cloud of vapor that shines softly, and from this coma stretch the luminous tails that make comets so unforgettable. One tail is made of dust, a glowing streamer reflecting sunlight, while the other is carved by the solar wind, a ribbon of charged particles always pointing away from the sun. Together they create a vision so striking that for much of human history, comets were seen not as natural phenomena, but as omens warnings written in fire across the heavens. When people in the past looked up and saw a comet blazing through the sky, they believed it heralded change, disaster, or the will of the gods. Kings fell, wars began, plagues swept across lands, and still comets appeared, unbidden and unexplained. Their suddenness was part of their power, for unlike the steady cycles of planets and stars, comets were irregular, unpredictable intruders into the orderly heavens. To ancient eyes, they seemed alive, fiery messengers carrying news from beyond. Only later did science reveal them as frozen remnants of the solar system's birth, time capsules preserving the chemistry of 4.6 billion years ago, untouched by the processes that reshaped planets and moons. They are not heralds of doom, but messengers of memory. Among them, Halley's Comet is the most famous, its visits recorded through centuries like clockwork within chaos. Halley returns every 76 years, long enough that most people see it only once in a lifetime, yet frequent enough that its appearances weave through human history. It was painted in medieval tapestries, feared by emperors, and celebrated by astronomers who began to realize its predictable path. To see Halley's Comet is to share an experience with countless generations before, all looking up at the same visitor, blazing briefly before fading again into the dark. Hale-Bopp, another brilliant traveler, lit the skies in 1997 with a brilliance that stretched across weeks, visible even in cities where most stars are drowned by light. It was a reminder that comets are not rare, only patient, waiting for the right nudge to send them inward, where they glow against the velvet of the night. The Oort cloud, believed to be the birthplace of long-period comets, is a sphere of icy fragments surrounding the solar system at unimaginable distances. It is not something we have seen directly, but inferred from the behavior of comets that take thousands, even millions of years to orbit the sun. These comets are like distant exiles, stirred by passing stars or the subtle tug of the galaxy itself, falling inward to make a brief appearance before vanishing again into the abyss. The Kuiper belt, closer in, produces shorter period comets, their orbits measured in decades or centuries. Together, these reservoirs hold countless bodies, icy wanderers that form the solar system's shadow archive, remnants preserved far from the warmth that transforms them. To look at a comet through a telescope is to see not just an object, but a process unfolding. Its surface vents, its gases glow, and its tail streams behind it for millions of kilometers, a spectacle born of nothing more than sunlight touching frozen dust. And yet, those tails always point away from the sun, even when the comet moves outward again, a reminder that comets are shaped not only by their own momentum, but by the invisible winds that sweep the solar system. Each one carries with it water and organic molecules, ingredients that may once have seeded Earth itself. Some scientists believe comets delivered the first water to our young planet, crashing down in countless impacts and leaving behind oceans where life could begin. If so, then the wanderers are not just visitors, but ancestors of life, quiet bearers of possibility, drifting through time. The surfaces of comets are stark and jagged, scarred by eruptions and collapses as they heat and cool. The Rosetta mission, which orbited Comet 67P, Churyumov-Gerasimenko, revealed cliffs of ice, dusty plains, and jets erupting like geysers, casting material into space. The comet was no smooth snowball, but a rugged world, strange and alien, with its own landscapes shaped by rhythms millions of years old. Watching it breathe under the touch of the sun was like watching a stone awaken, its frozen heart releasing vapor into the void, whispering secrets from the solar system's dawn. Even when comets vanish from view, they leave behind traces. Some of the most familiar meteor showers, like the Perseids and the Leonids, are born from comet dust. Each year, Earth passes through streams of particles shed by comets long gone, and those particles flare as they enter the atmosphere, creating streaks of light across the sky. What seems like a brief wish or falling star is, in truth, a fragment of a comet, burning brightly before disappearing forever. In this way, comets continue to touch us, even when they are nowhere near, scattering their remnants like breadcrumbs along their ancient paths. Comets are contradictions made real, both fragile and eternal, predictable and surprising, dead and alive. They are fossils of the solar system's youth, yet when warmed, they come alive with activity, hissing, venting, and glowing. They are solitary, yet they connect past and present, Earth and cosmos, science and myth. They remind us that the solar system is not a fixed arrangement of planets, but a dynamic, evolving place where visitors still come from the farthest reaches. To follow a comet's path is to trace a story that began before there was an Earth to see it. It is to watch frozen memory thaw, to see chemistry awaken into beauty, to witness the smallest of bodies write the largest of signatures across the sky. And when they depart, fading into the outer dark for centuries or more, they leave behind not silence, but anticipation. For somewhere in the cold, they are still moving, still waiting, carrying the past forward, ready to return when the solar system calls them home again. Every night, without fanfare, Earth drifts through clouds of dust that have been waiting for millions of years. Some of these particles are as small as grains of sand, fragments left behind by ancient collisions, comets, or shattered asteroids. Most go unnoticed, dissolving silently in the atmosphere. But every so often, one streaks across the sky in a sudden blaze of light, and for a heartbeat, the heavens seem alive with fire. We call them shooting stars, though they are not stars at all, but fleeting messages written in dust and flame, sparks of the solar system's endless motion burning up above our heads. The story of these sparks begins with meteoroids, the smallest travelers in the cosmic hierarchy. A meteoroid is simply a fragment of rock or metal wandering through space, smaller than an asteroid, but still carrying within it the history of the solar system. When one of these fragments collides with Earth's atmosphere, Friction with the air ignites it, producing a meteor, the streak of light we see against the night sky. Most meteors disintegrate completely, leaving nothing behind. But on rare occasions, a piece survives the fiery descent, striking the ground. Then it becomes a meteorite, a tangible relic of the cosmos that can be held in human hands. These three words, meteoroid, meteor, meteorite, are stages of a single journey. From silent wanderer to fiery spectacle to ancient stone resting once again on Earth. Meteorites tell us stories that even planets cannot. Some are older than Earth itself, formed in the earliest days of the solar system before our world coalesced from gas and dust. They carry within them minerals forged in the first bursts of star-born elements, chemical fingerprints that speak of times before our planet had oceans or skies. Holding a meteorite is not just holding a rock, it is cradling a fragment of the universe's deep past, a piece of history that predates mountains, seas, and even life itself. Many are no larger than a pebble, yet they are time travelers, carrying memories from billions of years ago into the present. But sometimes, the arrival of a meteorite is not subtle. Earth's surface bears scars from impacts that were anything but gentle. 65 million years ago, a massive asteroid or comet fragment struck near what is now the Yucatan Peninsula, leaving behind the Chicxulub crater. The impact unleashed energy equivalent to billions of nuclear bombs, throwing dust into the atmosphere, blocking sunlight, and altering the climate. Dinosaurs, which had ruled for over 160 million years, vanished in the aftermath, along with countless other species. That single collision reshaped the course of life on Earth, making space for mammals, and eventually humans, to rise. Long before history was written, the heavens had already rewritten the fate of the world. Even smaller impacts leave their marks. In the Arizona desert lies Meteor Crater, a vast bowl nearly a mile wide, created about 50 years ago when a relatively modest iron meteorite struck the ground. Its explosion would have been catastrophic to anything nearby, though humanity had not yet reached that part of the world. The crater remains today as a reminder of the immense energy carried by even small fragments of the cosmos. In 1908, the Tunguska event flattened thousands of square kilometers of Siberian forest when a space rock exploded in the atmosphere. More recently, in 2013, a meteor exploded above Chelyabinsk, Russia, shattering windows, damaging buildings, and injuring over 1,000 people. The blast came from a rock barely 20 meters across. These events remind us that though rare, the sky is not entirely benign. Earth is part of a larger system, and sometimes the system sends us fiery reminders. Yet most meteors do not threaten or scar, they enchant. Each year, as Earth orbits the Sun, it passes through trails of debris left by comets, and when it does, meteor showers paint the night. The Perseids in August, born from comet Swift-Tuttle, scattered dozens of meteors across the sky each hour, their streaks bright and fast, like sparks falling from an unseen fire. In November, the Leonids return, fragments shed by Comet Tempel-Tuttle, sometimes erupting into storms with thousands of meteors visible in a single night. To lie beneath such a sky is to feel the universe alive in motion. Every streak, a fragment of something ancient, igniting for an instant before vanishing. These showers are regular, predictable, and yet they never lose their magic. Each one is a performance choreographed by the cosmos, carried out on a stage that stretches across the vault of heaven. Even the smallest meteor carries with it a sense of connection. It is not just light, it is matter, a real object colliding with our atmosphere, burning so brightly that we can see it from hundreds of miles away. For a brief moment, it bridges the gulf between space and Earth, between the distant and the immediate. Some cultures saw meteors as messages from gods, others as the souls of the departed, still others as omens of change. Today, we understand them scientifically, but their beauty remains untouched by explanation. A streak of light across the dark sky is more than data, it is wonder. Meteorites, when recovered, allow us to study the chemistry of the solar system's beginnings. Some contain amino acids, the building blocks of life, hinting that the seeds of biology may have been delivered to Earth from the stars. Others are fragments of Mars or the Moon, blasted away by impacts and flung into space before eventually falling to Earth. To pick up such a stone is to hold a piece of another world, carried across the void to rest in our hands. These are not ordinary rocks, but fragments of planetary stories, delivered like letters from elsewhere, written in the language of minerals and isotopes. And yet, even when we cannot hold them, meteors themselves are gifts. They remind us that Earth is not alone, not isolated, but part of a grand dance of objects that move, collide, and change. Most are harmless, fragile particles no bigger than a grain of sand, disintegrating long before they can touch the ground. Yet their light is enough to make us pause, to look up, and to remember that above our busy lives stretches a cosmos vast and in motion, still capable of wonder. On a quiet night, if you find yourself beneath a dark sky, far from the glare of cities, you may see them. A sudden spark, a swift blaze, gone almost before you can breathe. They are not stars, but dust. Not eternal, but fleeting. And yet, in their brevity, they carry something timeless. They are whispers from the ancient past, sparks of creation burning themselves away to remind us that the universe is not silent. It falls around us in sparks, in fragments, in light. And every shooting star is a reminder that we live inside a living system, one where even the smallest grains can illuminate the dark. Out in the great dark, where planets drift in silence and stars burn with indifferent fire, there are forces we cannot see but that shape everything. They do not glow, they do not shimmer, they do not announce themselves with spectacle. Yet without them, the solar system would scatter into dust, its delicate balance undone. Gravity, magnetism, charged winds, and radiation, all of them invisible threads, weaving together the structure of our cosmic neighborhood. To live here is to move constantly within their grasp, whether we notice them or not. Gravity is the oldest and most patient of these forces. It is the quiet sculptor that carved planets from chaos, drawing dust into clumps, clumps into worlds, and worlds into orbits that have endured for billions of years. The sun's gravity holds the entire solar system together, commanding planets to circle in endless revolutions, moons to follow their parents, comets to loop in long arcs before retreating to the dark. It is a pull we never feel directly, because it is the very stage beneath our feet, the reason our bodies rest on Earth instead of drifting away. Without it, nothing we know would exist. Not oceans, not air, not even the ground itself. Gravity is silent, invisible, but in its patience lies permanence. Yet gravity is not the only unseen influence. Around each planet with a molten heart or magnetic core stretches a shield, a magnetosphere that bends and channels the endless stream of charged particles flowing outward from the sun. These particles, known as the solar wind, race across the solar system at hundreds of kilometers per second, a ceaseless gale of plasma that would strip away atmospheres and batter surfaces if left unchecked. Earth's magnetic field captures and deflects much of this wind, steering particles into looping paths that follow invisible field lines. At the poles, some particles slip through, colliding with our atmosphere and igniting into curtains of green and violet light, the auroras, living proof of an invisible shield at work. Without this field, Earth's oceans might have been boiled away long ago, just as Mars's thin air was slowly peeled from its grasp. The solar wind itself is born deep within the sun. Inside its core, fusion releases more than light. It stirs particles into streams that cannot be contained, so they escape into space as a perpetual outflow of plasma. The wind carries the sun's influence far beyond the planets, sweeping past Pluto and the Kuiper belt, until, At last, it slows and collides with the thin matter between the stars. This bubble, vast and unseen, is the Heliosphere, and we live entirely within it. It is our sun's invisible territory, a shield against some of the harshest radiation drifting through the galaxy. The boundary of this bubble is unimaginably distant. Voyager 1, traveling for more than 4 decades, only recently crossed it, leaving behind the protective breath of the sun and entering true interstellar space. We exist inside this envelope without feeling its edge, cocooned in a frontier shaped by an unseen wind. Beyond the solar wind, other invisible travelers pass through us every moment. Cosmic rays, high-energy particles accelerated by distant supernovae or black holes, streak across the galaxy, slipping into our system, through our atmosphere, and into our very bodies. They arrive without warning, silent and unstoppable, tiny fragments of distant cataclysms that still echo here. Most pass through us without effect, ghosts from long-dead stars that we never notice. But they remind us that the solar system does not exist in isolation. It breathes in radiation and energy from the wider cosmos, touched constantly by the remnants of explosions light-years away. The invisible is not always gentle. Solar storms, born from eruptions on the sun's surface, sometimes hurl massive clouds of charged particles into space. When one collides with Earth's magnetosphere, it can trigger geomagnetic storms, disrupting satellites, interfering with power grids, and painting the skies with auroras that stretch far from the poles. These storms are reminders that even with shields and balances, the solar system is alive with forces we cannot command. What looks like calm starlight is, in truth, a place of constant movement and restless energy. And still, gravity endures as the steady counterpoint to all this turbulence. It keeps planets circling in near-perfect harmony, balancing the pull of the sun against the inertia of motion. Moons tug on their planets and raise tides. Planets tug on each other, shifting orbits ever so slightly in resonances that echo across eons. Even tiny asteroids, wandering near giants, are bent and nudged by gravity's hand, their fates written in arcs and ellipses rather than lines. The ballet of the solar system is not choreographed by chance but by this invisible embrace, a law so constant that we forget it is there until reminded by the pull of the sea or the fall of a stone. Magnetism, gravity, radiation, wind, each of them alone is powerful, but together they form the unseen framework of the solar system. They shape what we cannot see directly, why Earth is habitable, while Mars is barren, why comets return in long intervals, why the sky glows with shifting curtains of light, and why distant spacecraft continue their journeys wrapped in the sun's fading breath. These forces are not decoration or background. They are the very essence of why the solar system holds together as it does. To look into the night sky and see stars and planets is to see only half the truth. The other half lies in what cannot be seen, only inferred through motion, light, and the faintest of signals. It lies in the pull that keeps Earth steady, in the shield that bends particles away, in the distant hum of rays from stars we will never know. We live not just among planets and moons, but within a sea of invisible currents that guide us, protect us, and sometimes threaten us. And so, as you drift to rest, remember that even now your body is being touched by these hidden forces. Gravity holds you close to Earth. The magnetosphere deflects particles above your head. The solar wind races past, pushing outward into space. Cosmic rays slip silently through you, reminders of ancient explosions far away. You are never apart from them. You are carried within their quiet embrace, shaped by what you cannot see, a participant in the invisible threads that bind the solar system together. The solar system is never still. Though from Earth, the stars seem fixed, and the planets drift slowly, almost predictably. The truth is that every body is in constant motion, pulled and nudged by forces both gentle and immense. Planets orbit the sun in grand ellipses, Moons circle their planets in smaller arcs. Comets trace paths that stretch into the deep cold. And even the sun itself wobbles slightly, tugged by the gravity of its companions. From the smallest grain of dust to the largest giant planet, nothing is at rest. Motion is the solar system's heartbeat, steady yet never simple, an ancient rhythm that has endured since its birth. Each planet follows a path around the sun, an orbit shaped by gravity and momentum. These orbits are not perfect circles, but ellipses, elongated ever so slightly, bringing planets nearer to the sun at one point and carrying them farther away at another. Earth, for instance, draws closer in January and drifts farther in July, though the difference is subtle. Over millions of years, even these orbits shift, stretched or compressed by the gravitational pull of other planets, particularly the giants. Jupiter and Saturn especially exert their influence, their vast masses tugging on their smaller neighbors, weaving hidden connections across the solar system. These connections often take the form of resonances, where the orbits of planets or moons fall into exact ratios. Pluto, for example, is caught in a resonance with Neptune, orbiting the Sun twice for every 3 of Neptune's journeys. This dance ensures that the two bodies never collide, their motions locked in a repeating pattern that has endured for millions of years. The moons of Jupiter also move in resonance, with Io, Europa, and Ganymede, linked in a rhythm of orbits that keeps them stirring and shifting inside, their surfaces reshaped by tidal forces. These resonances reveal that motion is not random but patterned, a choreography set by gravity's pull, repeating endlessly like music carried on a cosmic scale. Yet the solar system has not always looked as it does now. In its youth, the giant planets are believed to have migrated, drifting inward and outward, reshaping the system as they moved. Jupiter may have traveled closer to the Sun before being pulled back by Saturn's influence, a migration that scattered asteroids and perhaps prevented another planet from forming between Mars and Jupiter. Neptune, too, likely shifted outward, pushing smaller icy bodies before it, sculpting the Kuiper belt and scattering comets into distant orbits. These migrations were slow, measured in millions of years, but their consequences were profound. The solar system we see today is the product of these long drifts, a structure carved not only by where planets were born but by where they traveled. On even longer timescales, subtler motions reshape the system. Earth's axis wobbles in a cycle called precession, slowly shifting the orientation of our planet's tilt over tens of thousands of years. The angle of that tilt changes too, altering how sunlight falls across the globe and shaping the rhythm of ice ages. The orbits of planets stretch and tilt, their eccentricities and inclinations shifting under the influence of one another. These cycles, though imperceptible in a single lifetime, accumulate into vast patterns that influence climate, geology, and the possibilities of life. The solar system is not static, but dynamic, its motions resonating not only in the heavens, but in the history of Earth itself. Amid these patterns lies chaos. The gravitational pull of many bodies interacting at once creates systems so complex they cannot be perfectly predicted forever. Over billions of years, small uncertainties in position grow into vast uncertainties in outcome. The motions are stable on human timescales, but in the far future, orbits may shift unexpectedly, asteroids may be nudged into new paths, and moons may wander from their parents. This chaos does not erase order, it coexists with it. The solar system is both clockwork and storm, a place where cycles repeat faithfully and yet surprises still emerge. Consider the way planets tilt relative to the Sun's equator, each inclined at a different angle, none perfectly aligned. Mercury's orbit tips one way, Neptune's another, while Pluto's path leans steeply compared to the rest. These inclinations create a layered, tilted system, like rings of dancers moving around a stage at different angles. Over time, these inclinations shift subtly, stirred by the pulls of neighboring planets and the sun's own gravity. Nothing is perfectly flat or perfectly straight. Motion bends, tilts, and weaves, adding complexity to the cosmic dance. The solar system's cycles extend into realms beyond sight. The Oort cloud, if it exists as we believe, is influenced not only by the sun, but by the distant tides of the Milky Way, its icy bodies stirred by passing stars and clouds of interstellar gas. These encounters, rare but inevitable, send comets falling inward, reminding us that the solar system does not exist in isolation, but is part of a larger galactic current. Even the sun orbits the center of the galaxy, pulling the planets with it as it circles once every 230 million years. Our solar system is not only in motion within itself, but also in motion through a greater whole, a smaller dance within a larger one. Motion defines time. The years we count are Earth's journey around the sun. The months trace the orbit of our moon. The days spin from our planet's rotation. Even the rise and fall of ice ages follow cycles written into Earth's shifting orbit. Without motion, there would be no time as we know it, no seasons, no rhythm to measure life against. The solar system is not simply moving. It is the reason time flows in a way we can feel and measure. Yet this clock does not tick evenly. Some cycles are swift, others slow, some predictable, others unstable. It is not the ticking of a perfect machine, but the flowing of a river, currents overlapping and colliding, eddies forming within larger tides. Planets sweep in elegant arcs, moons circle in resonant steps, comets dive in and out, all of them carried in patterns too vast for us to see in their entirety. We are inside the clock, watching the hands move but unable to see the whole mechanism at once. To stand beneath the night sky is to glimpse only the surface of this motion. The stars appear fixed, though they too move, and the planets wander slowly among them. A meteor streaks briefly, the moon drifts from night to night, and the sun rises and sets with a rhythm so steady it feels eternal. But behind this regularity lies depth, a tapestry of cycles, precessions, inclinations, migrations, and resonances. The solar system is not a still picture but a dance in which every step influences the next, every motion echoes across time. And so the solar system continues, both orderly and unpredictable, stable and restless, a cosmic clock that does not tick evenly but keeps time all the same. It is a reminder that motion is not only background but essence, the fabric upon which planets, moons, and life itself are written. To live here is to move with it, carried endlessly within a dance older than memory and destined to outlast us all. The farther you travel from the sun, the quieter the solar system becomes. The warmth of sunlight weakens, spreading thin until it feels no stronger than the dim glow of a distant lantern. The familiar worlds, planets with their moons, belts of asteroids and comets fall away behind you, and in their place lies a frontier both vast and mysterious. Here, at the edges of the solar system, the sense of home begins to dissolve, and the domain of our star blurs into the greater darkness of the galaxy. It is not a sharp line, but a fading gradient, where gravity still holds sway yet grows weaker, where particles from the sun still flow but eventually yield to the winds of other stars. Just beyond Neptune lies the Kuiper belt, a broad expanse of icy bodies circling the sun in wide, slow orbits. This is no empty region, but a realm as rich as the asteroid belt, only larger and colder, populated by frozen relics of the solar system's youth. Pluto, Eris, Haumea, and Makemake are only the most famous residents, but there are billions more, small and silent, tumbling along paths that may take centuries to complete. Their surfaces are sheathed in frozen methane, nitrogen, and water ice, preserved for billions of years in temperatures so low that even the faint warmth of the sun cannot thaw them. They are fossils of creation, fragments left behind when the planets grew and migrated, too distant to be consumed, too cold to change. Yet the Kuiper belt is only the beginning. Beyond it stretches the scattered disk, a region of even stranger orbits, elongated and tilted, the tracks of objects pulled outward by Neptune's gravity or flung far by the migrations of the giant planets long ago. These scattered worlds wander in eccentric loops, sometimes diving inward near Neptune, sometimes stretching far into the outer dark. Among them are detached objects like Sedna, whose orbit carries it so far that it spends most of its long journey thousands of times farther from the Sun than Earth. These distant bodies move on timescales so immense that human history is only a flicker compared to one of their orbits. To contemplate them is to feel the immensity of time itself, measured not in centuries, but in millions of years. And then, farther still, beyond what we can yet see directly, lies the Oort cloud. It is believed to be a vast shell of icy fragments surrounding the solar system, extending almost halfway to the nearest stars. No telescope has ever imaged it, and no probe has reached it, yet its existence is written in the comets that appear in our skies. Long-period comets, those that take thousands or millions of years to return, are thought to come from this distant sphere. It is as though the solar system wears a cloak of frozen bodies, an unseen halo that marks its true reach. Each icy fragment drifts silently in the cold, stirred now and then by passing stars or the faint tide of the galaxy, sent inward as sudden messengers that blaze briefly before disappearing again. The Oort cloud is not just a boundary, it is an archive, holding the remnants of the nebula that gave birth to everything we know. Closer to us, where the sun's influence fades, lies the heliopause, the point where the solar wind streams of charged particles flowing outward meets the interstellar medium. It is the true edge of the sun's breath, the boundary where the bubble of the heliosphere ends and the wider galaxy begins. This boundary is not sharp, but shifting, shaped by the push and pull of stellar winds and magnetic fields beyond. To cross it is to leave the solar system in the strictest sense, to step outside the protective envelope of our star and into the interstellar sea. Only two human-made objects have done so. Voyager 1 and Voyager 2, launched in 1977, now drift beyond the heliopause, carrying with them the whispers of human presence. They are fragile craft, powered by the slow decay of radioactive fuel, their instruments aging yet still listening. Each carries a golden record, etched with sounds and images of Earth music, greetings in dozens of languages, the laughter of children, the roar of the surf. They sail outward not to be heard, perhaps not even to endure, but to declare that we were here, that we looked outward and sent a part of ourselves to drift among the stars. The Voyagers are more than machines. They are our message in a bottle, cast into a sea so vast we cannot imagine its shore. At the edges, the solar system feels less like a place and more like an idea, a domain defined not by solid surfaces or familiar skies, but by forces and boundaries unseen. Gravity stretches endlessly, never fully ending, but growing weaker until the pull of other stars becomes equal to that of the sun. The solar wind pushes outward, but eventually it yields to winds from other suns, mingling and vanishing into the larger galactic current. The Oort cloud, if it is truly there, is less a wall and more a fading presence, a mist of frozen worlds thinning into nothing. The edge is not a border to be crossed, but a transition, a place where belonging fades into the unfamiliar. Yet these outer regions are not empty. They are alive with questions. What lies hidden among the scattered disk, where Sedna and its kin wander? Could there be another unseen planet, a distant giant shaping their paths from the shadows? What stories do the icy fragments of the Oort cloud hold about the dawn of the solar system? We do not yet know. The edges are the least explored, the most mysterious, the frontier that tempts our imagination to dream of what lies beyond. To stand at the edge of the solar system, if such a place could be found, would be to stand at a threshold. Behind you would lie the sun, still a bright star but no longer dominant, its warmth just a memory carried in the light that has traveled billions of kilometers. Ahead of you would stretch the galaxy, with its countless stars, each with its own worlds and mysteries. The boundary would not be a wall but a blur, the end of one story and the beginning of another. And so the solar system continues, stretching outward farther than we can yet reach, ending not in certainty, but in mystery. It is a home without walls, a domain defined by fading influences and unseen shells, a place where the known dissolves into the unknown. At its edges, we are reminded that our sun is not the center of all things, but one among billions, that even the vastness we call home is only a small island in a greater sea. The blurred boundary is not a limit, but an invitation, a whisper that beyond home lies more, always more, waiting in the dark. You sit beneath the night sky, looking up at the pinpoints of light scattered across the dark, and perhaps you feel small. The solar system seems vast, a collection of giants and wanderers, rings and storms, icy plains and blazing furnaces, all moving endlessly in their ancient dance. Yet you are not separate from this story. You are woven into it, carried within its fabric. The same forces that hold the planets in orbit hold you to the Earth. The same light that warms the frozen plains of Pluto shines upon your face. The solar system is not only out there, it is within you. The atoms of your body tell its history. The carbon in your cells, the oxygen in your lungs, the calcium in your bones, the iron in your blood, all of them were forged long before you drew your first breath. Some came from the heart of stars that lived and died before the sun was born, scattered across the galaxy in the violent exhalations of supernovae. Some were formed in the quiet fusion that still burns within the sun, light and heat flowing outward to sustain life on Earth. Every breath you take carries molecules once shared by ancient forests, oceans, and even the earliest life. You are, quite literally, the universe remembering itself in human form. The planets and moons are your neighbors, not distant strangers. The tides that rise and fall along Earth's shores are guided by the moon's steady pull. The storms on Jupiter shield Earth by capturing wandering comets and asteroids that might otherwise strike. The sun's warmth drives the winds and seasons, the cycles of growth and rest that shape the rhythms of your life. Even the faintest particles streaming from the solar wind brush past you, and cosmic rays from beyond the stars pass silently through your body. You are never apart from these forces. You are always within them, carried by their currents as surely as Earth itself is carried through space. And yet, as much as the solar system has given us, it is not eternal. Far ahead in time, long beyond the span of human memory, the sun will change. Slowly it will exhaust the hydrogen in its core, and when that fuel is gone, it will swell into a red giant, its outer layers expanding until they engulf Mercury, Venus, and perhaps even Earth. For a time, the sun will blaze brighter and larger, reshaping everything that remains. Eventually, it will shed its outer shells into space, leaving behind a white dwarf, a cooling ember that will fade over billions of years into silence. The solar system will not end in sudden violence, but in slow transformation, its light dimming as time stretches on. But that future is not a cause for fear. It is part of the same cycle that created us, the endless rhythm of birth and death that governs stars and galaxies alike. Just as earlier stars gave their elements to form the sun and planets, so too will the sun one day return its matter to the galaxy, seeding future systems with the elements that sustain life. The solar system's story does not end. It continues, written into other skies, other worlds, perhaps other beings who will one day look up at their night sky and wonder about their place in it. For now, we live in the moment between beginnings and endings, in the long middle chapter of the sun's life, where warmth and stability allow oceans to glisten and forests to breathe. We live in a solar system alive with motion and mystery, where moons hide oceans beneath their ice, where comets awaken from slumber, where planets swirl in their patient orbits. and where distant probes carry our whispers into the dark. We are part of this story not as observers but as participants, born from its materials, shaped by its forces, and destined to return to it in time. So when you look upward, know that you are not gazing at something foreign. You are seeing your own history written in light. The same atoms that fall as meteors across the sky once drifted in the same cloud that gave birth to Earth. The same water that fills comets drips in your veins as blood, and in your cells as life. The same gravity that pulls moons across the sky holds your feet steady on the ground. You are as much a child of the solar system as any planet, as any star, as any drifting fragment of ice at the edge of the Oort cloud. One day, humanity may wander farther, stepping beyond Earth, perhaps even beyond the solar system itself. We may walk on Mars, swim in Europa's oceans, or build observatories on Titan's lake shores. We may send ships outward to cross the heliopause, following in the path of Voyager, not as messengers, but as explorers. Wherever we go, we will carry this solar system within us, not only in memory but in essence. It is the foundation of who we are, the cradle from which we rise. And tonight, as you close your eyes, let the thought settle over you like a blanket. You are not small in this story. You are vast, because you are made of it. Every breath you take, every beat of your heart, every thought you carry, is part of the solar system's unfolding. The same light that shaped Pluto's plains touches your skin. The same winds that streak across Neptune once brushed the edges of the Heliosphere. You are a note in the cosmic symphony, fleeting but essential, as necessary as any planet in orbit. Rest now, knowing that you belong to something greater than you can imagine. The solar system cradles you, carries you, shapes you. It has always done so, and always will, until the day it too transforms and gives itself back to the stars. You are part of this story, inseparable from its beginning and its end. And in this knowledge, let there be peace, for you are at home in the cosmos, held gently in the arms of light and time.